Okay, so we are already done with the introductory terms in statistics. So we will now proceed in a frequency distribution table for ungrouped data. So for example, this would be our data. So we have five numbers, 1, 2, 3, 4, and 5. Now, we need to determine the measures of central tendencies and measures of variation and measures of position. So as I go with the solutions, I'm going to also discuss what are those which also can be found in your handouts. All right, so if this would be the data that we will have, the first thing that we need to determine would be what we call the highest value. And then the second is the lowest value. So for the highest value and the lowest value, it's very easy to determine which should be the highest value and lowest value after rearranging our data from highest to lowest or from lowest to highest. So as you can see in our example, it's already arranged and it's very easy to determine which should be the highest and which should be the lowest. So as you can see, the highest value here is 5 and the lowest value is 1. Now, after determining the highest value and the lowest value, the next that we're going to solve is called range. And the formula of range would be highest value minus lowest value. So here, our range now would be 5 minus 1, which should be equivalent to 4. But what is range? Actually, range is part of the measures of variation. All right. So what do you mean by measures of variation? So the measures of variation would give you an idea how dispersed your data are. So meaning how far are your data from each other. But if you would observe now in our range among the measures of variation is the weakest because in using the range formula, you're just considering the highest and the lowest. All right? What do I mean? So, let us say I have these values. All right? So, let us say I have these values. Isn't it the range for this value would still be equivalent to 4? Even if you're going to observe in our data 1, 2, 3, 4, 5, they are dispersed, right? Because they are not the same. They are different from each other. But if you would observe on the problem that or the data that I've written, one is repeated 5 times. But even if it was repeated 5 times, the range is still 4. So how would you say that it's dispersed? So that's the reason why range is the weakest measures of variation. All right. So later you're going to know which would be the strongest among the measures of variation. So after determining the range, the fourth that we will determine is n. All right, n for statistics is always the number of our data. All right, the number of data. And here, n would be equivalent to 5. Right? So now I already have the highest value, lowest value, range, and n. The next would be determining now what we call our mean. And the solution for our mean would be the summation of all the x over n. So what do you mean by summation? So from the word sum, you're just going to get the sum of all the x. And those x are your data. So all we need to do would be to add 1 plus 2 plus 3 plus 4 plus 5. And we're going to divide it with n, which should be equivalent to 5. All right, so here, the answer here would be 3. So our mean is equivalent to 3. So after the mean, again, this mean is part of the measure of central tendencies. The next would be getting the median. And then last would be the mode. So median is also part of measures of central tendency. So what do you mean by measures of central tendency? So the measures of central tendency would give you an idea from your data where is the center. So there is a possibility that your mean, median, mode would be equal to each other, right? There is a possibility, but there's also a high chance that they are not. All right. So as you can see for the mean, there's a formula, the summation of x over n, and this is called an average value. All right. Average value, but it's still part of measures of central tendencies. For the median, this is called a positional value. Why is it called positional value? It is called positional value because for median, position is important. Very, very important. But in the median, there are two kinds of median. So what do I mean by that? So the first one is that if your n is odd. So if your n is odd, n being equivalent to 5 as our data, as we have in our data, there are 5. So it's very easy here to determine which should be the median because after rearranging your data from highest to lowest or from lowest to highest, you would observe that 3 here would be our median, right? So why? It is because it is at the center of your data and median is a positional value. Now, as I have said a while ago, there are two kinds of median. First would be if n is odd, all right? The second is if n is even, all right? So, an example for that is like this. So, what if our data would be 1, 2, 3, and 4? Now, you would observe here, after rearranging our data from lowest to highest or highest to lowest, the median would be found in the middle of 2 and 3. All right, in the middle of 2 and 3. And how are we going to get that value? So what we're going to do is what we call interpolate. And in interpolation, all you need to do is to add 2 and 3 and divide it with 2. Then therefore, 2.5 is our median. All right, so again, there are two kinds. If it would be odd, all you need to do is to rearrange it. If it would be even, then you interpolate. So as you can see now, our mean and our median are the same. They're equal, right? Again, as I have mentioned a while ago, it's possible. Now, the last measures of central tendencies is called mode. And mode is called a frequency value, all right? So a while ago, mean is called an average value, so you're just getting the average. Median is called positional value because position is important. Now, mode is a frequency value. So once we say frequency, how frequent a value would appear in your data. All right. So in mode, let us say again, an example would be like this. So 1, 1, 1, 1, 1, and 5, which is the example a while ago. If I'm going to determine the mode, I'm just going to determine which is the most frequent in my data. And you would observe here that the mode would be equivalent to 1. Why? Because 1 appeared 5 times in our data. So that is our mode. Now, let us say I'm going to give another data, set of data. What if this would be our data? 1, 1, 2, 2, and 5. What would be our mode? So our mode here would be 1 and 2. All right. So here, this is called a unimodal. The first one, this is called unimodal. And this is called bimodal. So then, therefore, if there would be a unimodal, bimodal, trimodal, you can have a multimodal in mode. Now, an example of a multimodal would be the data that we have. So 1, 2, 3, 4, and 5. Now, you would observe if I'm going to just determine which is the most frequent, 1, 2, 3, 4, and 5 appeared once. Then, therefore, here, our mode would be all our data. Why? Because all the 5 data that we have appeared only once. All right. So again, this is part of MCT. So for the measures of central tendencies, mean, median, mode, we have um, average value, positional value, and frequency value. In the mean, median mode, the values can be equal to each other. All right. But it's also possible that they are different from each other. All right. So continuing on again, as I mentioned a while ago, in number three, there is what we call the range, which is part of the measures of variation. So in the next number that we're going to solve now the variance. Now the variance is part of the measures of variation. All right. And the formula of your variance would be looking like this. So it is the summation of your x minus x bar over n minus 1. Now your x bar here is our mean. So here in our mean, this can also be the x bar. All right. So using the data above, or the data that we have, which is 1, 2, 3, 4, and 5, if I'm going to solve the variance so that I'm going to have an idea how dispersed our data are. So the summation would be the sum. The sum of what? The sum, sorry, this should have a squared. The sum of all, or the sum of the algebraic expression beside the summation notation. So what are we going to do here? We're going to repeat the process for all the data that we have, the algebraic expression beside the summation notation. So again, the first value that we have is 1 minus 3 squared. Again, where did I get 3? 3 was our mean a while ago. All right, so here, 3 was our mean. So the first data, or the first value that we have, is 1. So you're going to repeat the algebraic expression again and again up until you exhaust, or you use up all of your data. All right, so it would look like this. And then you're going to divide it with, our n is 5, so 5 minus 1. All right, so solving this should just be 4 plus 1 plus 0 plus 1 plus 4 over 4. Or this is 10 over 4, or this is 2.5. So the value of our variance would be 2.5. But in the measures of variation, the most important is our standard deviation. All right. Again, standard deviation would be MV. The standard deviation is the best measures of variation to use for us to know how dispersed our data are. And in the formula of our standard deviation, it would just be the square root of our variance. All right, so that would be S, the square root of 2.5, and our standard deviation would be equivalent to 1.5811. All right, then therefore, our data, suggests, according to our standard deviation, that the data would be 1.5811 far from each other. All right. Now, what if our data looks like this? If our data looks like this, 1, 1, 1, what would be the standard deviation? Since, as I have mentioned a while ago, in the measures of variation, we are determining how dispersed our data are or how far from each other is our data. Now, since our data, there are four values, but all of them are equivalent to 1, then therefore the standard deviation here would be equivalent to 0. Why? Because our data is not dispersed. All right, so number 9. Number 10 would be, the next is determining the measures of position. All right, in the measures of position, there are three kinds of measures of position. Okay, what do I mean? There are three kinds. There is what we call a quartile, right? There is what we call a decile, and then a percentile, right? All right. So again, quartile, decile, and percentile. So we will go first with the quartile. In the formula of our quartile, that would be QK would be equivalent to K over 4 multiplied to N plus 1. Now, the K, the subscript K or the variable K, for quartile, K would be from 1 to 4. Why is it from 1 to 4? Because quartile is divided into 4 parts. So that's the reason why we are going to divide our data into 4. Now, what's the difference of the quartile, decile, percentile from the measures of central tendencies? The measures of central tendencies only gives us the data or the value that we can find in the center. Now, the measure of position, just like a median, which is a positional value, the median gives us the center only. But for the measures of position, we can find whatever position we like. Because for quartile, it would be 25ths, 50, 75ths, and 100. For the decile, that would be for tens, 20s, 30s, 40s, because it's decile by 10. And percentile would be by ones, and we can find the first, the second position, the third, the fourth, up until the 100th. All right, the value. Now, so for example, our data would be looking like this. So 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10. Now, if I'm going to, let us say, look for the 75th, the Q3, how will I look for it? So if since this is Q3, following the formula above, that would be 3 over 4 multiplied to 10 plus 1. Why is it 10 plus 1? It's because we have 10 values. All right? And here, the answer here would be 8.25. What is this value 8.25? The value 8.25 would be where you can find your Q3. So where can I find my Q3? It would be around here. All right? But what is the value? All right? To determine the value of your Q3, the formula now that we're going to use, so Q3 value, would be this. So the whole number plus decimal number multiplied to highest value minus lowest value. So what do I mean by whole number, decimal number, highest value, lowest value? The whole number and decimal number would come from the solution that we had a while ago. So following this, so I'm going to erase this first. So following, the 8.25 value, so the whole number now would be 8, plus the decimal number would be 0.25. The highest value is 10. The highest value is 9, sorry, 9. And the lowest value is 8. Now, you would observe that why is it 9 and 8? Since Q3, since Q3 is here, then therefore, the highest value and lowest value would be 9 and 8. Because that's where you're going to find your Q3. So here now, this would become 8 plus 0.25 multiplied to 1. Adding them, it would be 8.25. Now, the position where we can find Q3 and the value where we can find Q3 looks like it's the same. It is because the value of this is 1, meaning meaning our data is dispersed by only 1. But if we're going to change our data, let's say 1, 5, 7, or whatever number that you can think of, the position and the value would be different following the formula. All right. Now, let's say we're going to now determine Q1. So Q1 would be 1/4 10 plus 1. 1/4 10 plus 1 would be equivalent to 2.75. So 2.75 Q1 would be here. All right. So for me to determine the Q1 value, so that would be following the formula, that would be 2 plus 0.75, 3 minus 2. Again, why 3 minus 2? It's because of this. So that would be 2 plus 0.75 multiplied to 1, which should be again 2.75. Again, as I have mentioned a while ago, it looks like it's the same, but it's because of the data that we have. So if you have a different data, you just follow the formula, you're going to find out that the position and the value would be different. Now, so that would be for quartile. Again, for decile, we have a different formula. Again, as I have mentioned, for decile, it would now be k over 10. All right? And then n plus 1. All right, now, so for decile, it would be 1 to 10. So the values that we could use, the values that we could use for k on decile would be 1 up to 10. Okay, same data. What if I solve D4? Again, D4, that would be following the formula 4 over 10, 10 plus 1. All right. 4 over 10, 10 plus 1, that would be 4.44. All right. 4.44, where is that? All right. Let's change the color. Okay. 4.44, then therefore my D4, my D4 would be around here. All right. 4.44. So again, following the formula to get my D4 value, that would be 4 plus 0.44 multiplied to 5 minus 4. So that would be 4 plus 0.44 multiplied to 1. So our D4 value would be equivalent to 4.44. And the last that we're going to determine would be the percentile. So the percentile would be, no? So for pk, that would be k over 100 n plus 1. So you would observe that the formula would be the same. The only difference is the denominator. For quartile, we're going to use 4. For decile, we're going to use 10. For percentile, we're going to use 1. Now, so for percentile, let's say I'm going to determine the P62.5. So what will happen? Again, that would be 62.5 over 100 multiplied to 10 plus 1. And the position would be the 6.8475th position. So 6.8475th position. So again, we're going to change the color. So 6.8475 would be here. So this would be P62.5. All right. So again, following the formula for my P62.5 value, that would just be 6 plus 0.8475 multiplied to 7 minus 6. That would be 6 plus 0.8475 multiplied to 1. And our value would still be 6.8475. All right, so there you go. So this would be what we're going to do if we will be dealing with ungrouped data.